All right, everybody. Welcome back. Here we are at the end of chapter 4. And oh, what a wonderful place to be. Okay, so in the last video, we used this exact same data. So I thought, you know what? I'm just going to do that again, because why not? So um, anyway, so consider 2004 to be year zero. Okay, yeah, we saw that before. Use regression to find an exponential equation to model the data. We've done that before, but I don't remember what it is. So let's go do it right now. Okay. And okay, so, oh, look, I've got all the data typed in there. So I'll go stat, right arrow, and then down to exponential regression. That's option 0. And right there, and let's see, was it 3 decimal places probably? Yes, it was. Okay, so let's write down that equation. We'll go, let me go just a little higher, I guess. Y equals 34,647.266 times 1.052 raised to the x power. Now you'll notice I didn't put an x there to say multiplication, because then I've got this symbol that's in one place it's a variable, in another place it's a multiplication symbol, and that can confuse the issue if your symbol represents two different things. So that is why I didn't use an x there. I could have just done a big dot, but I thought, I'll just put this guy in parentheses. Okay, so I believe we're done with part A, which we've done that exact thing before. Okay, so use your regression equation. Use the regression equation. To find the year, the population will reach 60,000. Okay, so we could, we can look at this and say, all right, well, the population is going up, and when we get to 2010, it's at 47,220. It's exponential, so as the years roll on, it grows faster and faster. So the amount it increases by each year will get bigger and bigger. So, you might guess, I don't know, like maybe 2015, maybe. I don't know. I'm going to guess that. I don't know what the answer is. And then I could, if I wanted, I could say 64,647.266 times 1.052 raised to the, let's guess, year 15. Or, 2015 is not year 15, because 2004 is year 0. So 2015 minus 2004 is 11. So the year 2015 is year 11. And that's hard to read. Okay. And we're looking for, what are we looking for? 60, when the population hits 60,000. Oh my gosh, that was pretty close. 60,512. So apparently I overshot the mark a little. Let's see what happens if we go to year 10. That might be too low. Probably is. Yeah. So about year 11 is going to be a really good estimate for us. Now you could do it that way, but amateur hour is now over. We are in college after all. So here is how we're going to do it. Okay. So we, as always, we want to get the x by itself. Let's see. So we said our y value is going to be 60,000. Okay. So we're going to divide both sides by this number out in front, 34,647.66. And I'm just going to extend the line there. Okay, there. I'm dividing both sides by it. Okay, so on the right side, they'll cancel. On the left side, I've actually got a, okay, so here comes my trusty dusty calculator. Let's see, 34,647.266. Looks like I left off the 2 right there. You probably noticed that already, but hey, I caught it before the video was over, so that doesn't count for extra credit. Okay. So we get 1 point. Oh, wait, I want to go back to the other color, just, to be consistent. Okay, 1.732 equals 1.052 raised to the x power. Okay. All right, so now how do we get this 1.052 away from the x? They're not being multiplied, so you can't just divide it away. And the 1.052 is not in the exponents. You can't just say, hey, I'll just raise both sides to the same power and that'll work. That's not going to cut the mustard. So here's what happens. When you, in chapter 4, when you're doing exponential functions and you're solving for x, and x is just floating around there in the exponent, you use what's called a logarithm. And so I'm not going to get into all the rules of logs. I'm just going to show you what you need to know. So you're going to write down log, and I'm going to have a number down here called the base. It's kind of a subscript. And then I'm going to have another number up here that's not a subscript. It'll be on the same line as log. Okay, so what number goes down here? Well, whatever the base of the exponent is, every time. So this number that's being raised to the x power always goes down there. And then this number that was just kind of floating along by itself, he's that second number, or she. All right. And so the idea of the logarithm, that was created along hundreds of years ago to handle situations just like this, to say, I'm trying to solve for something, but it's in an exponent. How do I solve for it? And so you convert it to log form. Hence, this is the spiritual component of the course. Let us all convert. So, so that's nice. X is now by itself, which is definitely a good thing. How do we do this? Glad you asked. So you'll notice if I go to alpha window, option number 5 says log base, alpha window 5, and you just type it in. There's other ways on this calculator to get to this same feature, and that's fine. If you know one of them and you want to do that, I don't care. Okay. And I can't read that, so let me go, there we go. And let's see, so 1 decimal place, so 10.8. 10.8 what? Well, we're solving for x, so that's the year. So, year number 10.8. So 2004 is year 0. We'll add to that 10.8. So toward the end of the year 2014, and that'll get it done. And that'll handle part B. All right. Now, part C is very similar to part B. The only difference is you're going to use 25,000 instead of 60,000. That's the only difference. Well, 25,000, that's smaller than our smallest population. So it's going to be into the past, which means we're going to expect a negative answer. All right. So, yeah, we might as well just give that a shot. Let's see. So let me do this. I'm going to get rid of some of this wonderful stuff. All right. And then I'm going to go 25,000. Okay. So once again, we're going to divide both sides by that number out in front that is not being raised to a power, the power of x, the power of voodoo. Voodoo? You do. Okay. All right. So then we get 25. But you know what? Here, let me just do it this way on my calculator and make it easier. Okay, and I get 0.723. Now, 0.723 equals 1.052 to the x. Okay, now we're going to go, okay, feel free to pause the video here and figure out what it's going to look like when we convert this equation to log form. Okay, hopefully you paused the video. So the number that goes here is the base of the exponent, and then the other number goes right there. And so let me go to my handy dandy calculator, and I'll go alpha window 5, 1.052.723. Okay, it looks like negative 6.4. So yeah, so 6.4 years before 2004. Okay, well that makes sense. Okay. So that would be our answer. And that's how you do this stuff. So once you get the hang of this whole log thing and what the process looks like that I just did, it's it's not a big deal. You're like, okay, yeah, it's about the same every time. That's kind of nice. Anyway, that's it for chapter 4.